Dear students, in last lecture we learned about the hygiene's IPs. Now today in this lecture we will see Ramsden's IPs. As in hygiene's IPs we have discussed that about its arrangement of lenses. Here also we will see about its construction. See, in this diagram you are able to see there are two plano-convex lenses, this field lens and this eye lens. Itself they are plano-convex and which having a focal length f, because the ratio of focal length in this Ramsden's eyepiece is 1:1, whereas in hygiene's eyepiece that ratio we learned that was 3:1, and these lenses are separated, see, by the distance 2 by 3 f. See, now you are able to see the distance between these lenses 2 by 3 f. The lenses are kept at that distance, and the curved surface of these lenses are facing towards each other, and due to which, due to what? Due to this curved surface which are kept facing towards each other, due to which the spherical aberration is reduced. Spherical aberration is reduced. Then another point, the field length is a little larger. See, we can see by our eyes field length is little larger than the eye length, and again it is larger than intermediate image. This intermediate image, and placed close to this image to allow much light as possible as through it. This light is traveling through this lens. The eye lens has a smaller diameter. Same time, the eye lens has a smaller diameter but carries out the actual magnification. In this way, the construction of this Ramsden's eyepiece we can see. Now the objective forms the real inverted image eye. This eye is formed by the objective, and it is a real inverted image of a distant object. Means object is at a distance, and this acts object for the field lens. This image acts as a object for this field lens, which gives rise to a virtual image. This is a virtual image I1, and again this I1 acts an object for the eye lens. This eye lens. This I1 is a virtual image which acts as object for the eye lens, which gives the final image at infinity. At infinity, we are getting the final image, and I1 is made to lie at its principal focus. Now, what about its equivalent focal lengths and all the things we will see here. See here about the construction and all these things you can see which are given here. You can read it, and if possible you can take a print also of this. The ratio of that lenses of having a focal length 1:1, it is given, and all these things. Then see, just we have been talked that about aberration, because if we are keeping the faces or curved faces surfaces facing to each other, due to which spherical aberration is minimized or reduced. Once again, we will see or discuss about the aberration. See, aberration, spherical aberration, chromatic aberration, astigmatism, distortion, and coma. All these are defects in optics. We can say optical defects. Defects means what happens when it is supposed that we have to get a clear image through any optical instrument, but due to some defect it is not getting, it is blurred or flickered, and that is one of the another topic to discuss the defects. But in this year or in this semester, we should only know about its terms. Therefore, now what to do for the removal of aberration in Ramsden's eyepiece? See, in this Ramsden's eyepiece, f1 equal to f and f2 equals to f. Means that field lengths and eye lengths, those having a focal length f, because the ratio is 1:1, and due to which d equal to 2 by 3 f. And if there is a chromatic aberration, then for removal of that chromatic aberration, what to do? We have to do d equals to f1 plus f2 by 2, means f1 plus f2, means this is 1:1, 1 upon 2, means 2 get cancelled and only f will be remaining here. And therefore, see here, for removal of spherical aberration, f1 minus f2 equal to 0. Therefore, this Ramsden's eyepiece in construction, it does not satisfy the required condition for minimizing the chromatic or spherical or other type of aberrations. But by using two thin plano-convex lenses which are facing the curved surface to each other, due to which up to some extent the spherical and other aberrations are avoided or minimized. Then what about the equivalent focal length? This is also one of the important part, and the equivalent focal length of the eyepieces can be found out by the following formula. In this formula, f is denotes the focal length of the equivalent focal length, and thereby 1 by f equal to 1 by f1, means f1 is the focal length of field length plus 1 by f2, focal length of the eye length minus d divided by f1 into F2. You see here we know the values of F1 and F2 is nothing but F and D equals 2 by 3F, and therefore by putting all these values in this formula we will get F, and this F is nothing but 3 by 4F. 3 by 4F is the equivalent length of a focal length, and this must be placed uh, behind the field lens at a distance. What should be the distance? We got here equivalent focal length, but if we got the length of this focal length, then where it should be kept? Therefore, for that purpose we have to find out. We can take here the notation alpha or x. Here we will take a x, that is f into d or d into f by f. See here, by calculating it, it should be f by 2. Thus we can say that the equivalent length which we have been calculated of focal length 3 by 4f, it should be lies between the field length and the eye length. Now, as we have discussed for the equivalent length, then where should be its cross wire? Again this question. Then the cross wire should be placed at the position of eye. Now the position of eye is relative to field length and can be found uh, by doing some calculations, but for keeping in mind the distance of eye should be equal to f equals to 3f by 4, and therefore the objective should produce the image at a distance of f by 4, which in front of the field length. A fine scale should be placed there for measuring the desired which we want to measure. Since the scale and image would be magnified equally and the measurement has been taken. Now what about principal and focal planes? See now, principal and focal planes means it is nothing but principal point, principal plane, focal point, focal plane, and these things means nothing but the cardinal points of Ramsden sites. See, first of all, for getting the idea, we will draw here, or already we have been drawn, the actual diagram of these cardinal points. Where should be? First of all, we will see in Ramsden cycles f1 equal to f and f. We are aware about it and all these things, and therefore alpha equals to f by 2. Means that first principal point or plane lies at a distance alpha equal to f by 2 from the field length towards right. From the field length towards right. See, if we want to see, yes, this is the diagram in which this is a field length, this is a eye length. Then what it, in which he is saying this much distance from L1 means from the field length L1, the first principal point and first principal plane is situated at a distance f by 2. And what about the second? Yes, for second principal point and second principal plane, beta, here is alpha, it is beta, and this is the formula. By keeping the values in this, we will get minus of f by 2, means the second principal point or of second principal plane lies at a distance minus of f by 2 from islands towards left. See, from the islands towards left. What is islands? This is islands. And this is f by 2. Where second principal point or second principal plane is situated in this way. What about the nodal points? See now, if the system means lens system is situated here, the nodal points coincides with the principal points. Means that if here is a P1, then there is also existence of nodal point N1, and here nodal point N2, and therefore because it coincides to each other. And what about the position of focal points? This f1 and f2 is situated. See, the equivalent focal length of the eyepiece, it is nothing but 3 by 4 f. Equivalent focal length of this eyepiece is nothing but it is a 3 by 4 f, which we have been already calculated. And if it is a 3 by 4, then the first focal point f1, this f1 lies at a distance 3 by 4 f, 3 by 4 f from the first principal point. This is the first principal point. This is lying here, first focal. And if we are going to draw a plane through this first focal point, then it will be first focal plane, and that is at a distance, we can say 3 by 4 f minus half f, minus half f equal to what remains? 1 by 4 f. 3 by 4 f minus half f is this remaining quantity, that is f by 4 to the left of the field length. This is a field length. From this field length, we have to plot first focal plane at a distance f by 4. And what about the second focal point? See here. The second focal point f2 lies at a distance 3 by 4 f from the second principal point P2. That is nothing but at a distance f by 4. Same thing as we have been calculated here, f by 4 behind the eye lens. This is the eye lens, and f by 4 is the distance behind the eye lens L2 away from the field lens. In this way, the focal point and focal planes can be plotted. See one thing which is important here, as we have discussed both the things, that is Ramsden's eyepiece and as well as Huygens eyepiece. The points which we should keep in mind are the points or a comparison in between Ramsden's and Huygens. See, the Ramsden's eyepiece always it is called as a positive eyepiece, whereas Huygens eyepiece is called as a negative eyepiece. See what happens about the image in Ramsden's eyepiece. The image formed by the Ramsden's eyepiece or the in this eyepiece, the objective lies in front of the field lens. Objective lies in front of the field lens. Therefore, the cross wires can be used. See, for getting the idea, in the diagram which we have been plotted here, yes. See here, the image formed by the objective lies in front of the field lens, and due to which the cross wires can be used. In Huygens eyepiece, what happens? In previous case, you having that video, you can see in that the image formed by the objective lies in between the two lenses. In Huygens eyepiece, if you are remembering the diagram, then the image formed by that Huygens eyepiece was in, we can say, in between the two lenses. Therefore, cross wires cannot be used. See now the difference. The image formation is in this side, in field lens. At the same time, in Huygens eyepiece, image formation takes place in between field lens and eye lens. Here the image formation takes place. This is the difference, and due to which in Huygens eyepiece cross wires are not used, cannot used. Keep in mind this point because these things can be asked in multiple choice questions. Means that again I am repeating these things. Ramsden's eyepiece is positive eyepiece. At the same time, Huygens eyepiece is negative eyepiece. Ramsden's eyepiece, in that eyepiece, cross wires can be used. In Huygens eyepiece, cross wires are not used. Then Ramsden's eyepiece is entirely free from chromatic aberration, but it is minimized by using an achromatic combination. See once again, a Ramsden's eyepiece is not entirely free. Because the ratio of field length and eye length of their focal length as 1:1, and therefore it is not entirely free. But at the same time, Huygens eyepiece is fully free from chromatic aberration because the distance between the lenses is equals to half the sum of their focal lengths. Means that in that case, in Huygens eyepiece, that ratio is 3:2. 3:2 means the distance between the lenses is equal to half the sum of their focal lengths, and therefore see the Huygens eyepiece having a ratio of 3:1. 3:1 means 3 plus 1 equals to 4, and the distance between them is equal to half. Means field length and eye length having a distance. In diagram you can see that distance was 2f. Clearly it was 2f. See, in next point we can say that the Ramsden eyepiece is used for quantitative purposes in microscopes and telescopes. Their quantitative purpose is there, and that area, in that area, the Ramsden eyepiece is used. Whereas in Huygens eyepiece, it is only used in qualitative purposes in microscopes and telescopes. In both these cases, in Ramsden's and Huygens eyepiece, the nodal points coincides with the principal points. In this way, we have been seen about the Ramsden's and as well as in previous case Huygens eyepiece clearly. Keep in mind the points of difference in both the cases, and by which you will be able to answer the multiple choice questions, and by which uh, we will finish these articles here. In next lecture we will discuss the next article. Thank you very much.